Hi, I'm an old guy and I do maths. Today we're going to try and find all possible solutions for this. Tan theta minus 1 times sine squared theta minus 3 cos squared theta equals 0 between 0 and pi for theta. Now, the solutions all involve tangents. There's the clue. Anyway, let's dispose of the first one, the easy one. In order to get this expression to equal 0, either this must equal 0 or this must equal 0. So let's deal with this. If the tan of theta equals 1, then this is equal to 0. 1 minus 1 is 0. So we consult our little triangles. And we see that the tangent of pi on 4 is equal to 1 over 1. So if theta is pi on 4, then its tangent equals 1, and this is rendered to 0. Multiply through by this, you get 0. This, I don't think there's a second tangent solution for this using pi on 4, because we would be moving into the second quadrant where tangents are negative. So the tangent of 3 pi on 4 would be a negative. We wouldn't get 0 as a result here. So that's our only solution between 0 and pi for this. However, it gets more exciting down the page. Let's have a look at this. So sine squared theta minus 3 cos squared theta equals 0. Now, in here, there's something that should alert a keen-eyed student to the fact that we've got a tangent solution for this, because we're dealing with sines and cosines. And the tangent of theta, for want of a better term, the tangent of alpha, whatever you want to call it, the tangent of an angle, is equal to the sine over the cosine. So let's see what we can do about that with this. Okay, well, let's get started. So our first move is to move sine squared theta. So if we move that to the other side of the equation, we've got negative cos squared theta equals negative sine squared theta. Okay, great. We can multiply through by negative 1 to get rid of the negatives. And what we then have is 3 cos squared theta equals sine squared theta. Nice and tidy. And minus the negative signs, which I always get tangled up in. I'm notorious for dropping negative signs as I do my working. So I just find it best to get rid of them as quickly as possible. Now, if we take the square root of both sides of this, we're going to get rid of this square here. And what we wind up with when we do that is the following. Plus or minus root 3, because the square root of 3 can be positive or negative, so plus or minus root 3, cos theta equals sine theta. A little bit of manipulation, a tiny move. Move the cos squared to here. Plus or minus root 3 equals sine theta over cos theta, which equals tan theta. We're back in the world of tangents, and that's how we resolve this. Now, here's the solution down here. And just let me talk you through this. Now, the first solution that we had up the top was pi on 4 over here, 45 degrees. If we had gone for a second solution, it would have been in the second quadrant and would have been negative. Now, let's see what we've got here. Tan theta equals plus or minus root 3. Consult our triangles again. And I should say here that I have never memorized the tables that you see in textbooks telling you what the sine, cosine, and tangent of pi on 3 is and all of those sorts of things. I memorized the two triangles. The little isosceles triangle up here with 45-degree angles, and this one here with 30, and 60. And that has served me well for decades. And it's kept my memory banks, which are eroding with age, it's kept my memory banks clear. Okay, so what we're looking for is we're looking for where tan theta is equal to plus or minus root 3 between 0 and pi. Well, where is the tangent of theta equal to root 3? Well, pi on 3, the tangent of that is root 3 on 1, which we commonly call root 3. Okay, so that's our starting point, root 3. That's one solution. Now, what's the other solution? Well, if we look over here, here's pi on 3 here. We can move over into this quadrant because we can have a negative here. So all signs are positive here, sines, cosines, and tangents, I should say. Sines are positive here, but tangents are negative, and that can give us the negative root 3. So we have two solutions for our problem, pi on 3 and 2 pi on 3. So in total, there are 3 solutions for this. These two here, and this one, where has it gone? Up the top here. And the second and third ones are the ones that are tricky. They're the ones where if you get this as a question, you really do make your marks. So this would probably be, I guess, a 3-mark question, maybe a 2-mark question. I don't know. I think it's a bit, if it's a 2-mark question, I think it's a bit cheeky to give 1 mark for this and 2 marks for these. I'd be much more inclined to give 1 mark for this and then 1 mark each for these. Anyway, that is how you do it. What we are looking for is we're simply looking to satisfy this equation between 0 and pi. And the real trick is to get to this point. Once you get here, it's easy. Thanks very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.